The James Webb Space Telescope, JWST, has been a game-changer in our understanding of the cosmos. With its advanced infrared technology, the telescope allows us to peer deeper into space than ever before, revealing structures and celestial bodies at unprecedented distances and ages. Recently, JWST announced a discovery that has left astronomers both astonished and puzzled: the detection of a massive structure that appears to be older than the universe itself. This enigmatic finding challenges our understanding of cosmology and raises intriguing questions about the nature of space, time, and the origins of the cosmos. When astronomers and physicists discuss the age of the universe, they typically refer to the period following the Big Bang, which is estimated to have occurred about 13.8 billion years ago. This event is widely accepted as the beginning of both time and space as we know it. After the Big Bang, the universe went through a period of rapid expansion known as inflation, followed by a cooling phase that allowed particles to form atoms and, eventually, galaxies, stars, and other cosmic structures. The age of the universe sets a fundamental limit on how old any object within it can be. The James Webb Space Telescope's observations, however, have brought this understanding into question. The telescope has recently observed a massive structure, believed to be a galaxy cluster, that appears to be older than the universe itself according to its estimated redshift or measure of distance and age. Redshift is a concept in astrophysics used to determine how far away an object is by analyzing the way light stretches as it travels through the expanding universe. The farther away a galaxy is, the higher its redshift, meaning we are seeing it as it was farther back in time. But with this particular structure, astronomers encountered an anomaly. Its redshift indicates an age that exceeds the universe's expected 13.8 billion years. The implications of such a discovery are monumental. If the structure is indeed as old as its redshift suggests, it would mean that our current understanding of the Big Bang and the formation of the universe is incomplete, if not outright incorrect. This finding could suggest that there are aspects of physics we don't yet fully understand or phenomena beyond the standard model of cosmology. Some scientists have speculated that this structure might represent evidence of a multiverse or an alternate cosmic timeline, where different universes with varying ages and properties coexist. Others have suggested that our calculations of the universe's age could be off, hinting that it might be older than 13.8 billion years. Another possibility is that this structure is an illusion of sorts, a quirk of the way we interpret redshift data. There are rare and unusual phenomena, such as gravitational lensing, where massive objects in the foreground can warp spacetime, bending and magnifying the light from objects behind them. This effect can create the appearance of older, farther away objects than actually exist in that region of space. If gravitational lensing is at play here, it might explain why this structure appears older than it should be. But even with gravitational lensing, the extent of the observed redshift remains puzzling, as it exceeds what we would typically expect to see. The existence of a structure seemingly older than the universe also raises questions about the nature of time and space themselves. In Einstein's theory of relativity, space and time are intertwined in a continuum known as spacetime, where massive objects create distortions that affect how time flows. These distortions, however, are relatively small in most parts of the universe. For an object to appear as old as or older than the universe, it would require a significant deviation in the way we understand time and space to interact on cosmic scales. This could mean that time in certain regions of space behaves differently from time as we experience it, suggesting the potential for time dilation on a universal scale, where certain areas of the cosmos experience time at different rates. In response to these mysteries, some scientists are revisiting alternative theories about the universe's formation. For instance, one theory known as the cyclic model proposes that the universe undergoes endless cycles of expansion and contraction. According to this idea, the Big Bang may not have been the absolute beginning of time but rather a reboot of the universe following the collapse of a previous cosmic phase. If the cyclic model holds any weight, the detected structure could be a remnant from a past cycle, a relic of an older universe that existed before our own Big Bang. Another concept gaining traction is the idea of dark energy and its role in shaping the universe. Dark energy, an invisible force driving the accelerating expansion of the universe, is one of the least understood phenomena in modern physics. If dark energy behaves differently in various regions of the cosmos, it might create irregularities in the flow of time and the structure of space. Such a discrepancy could account for the structure's unexpected age, suggesting that certain cosmic phenomena may follow rules distinct from those governing observable matter. The JWST's discovery has further implications for the search for extraterrestrial life and the understanding of cosmic evolution. If structures older than the universe are indeed possible, they might represent regions where conditions have existed long enough for advanced civilizations to develop. This hypothesis, while speculative, opens up new questions about the potential for ancient civilizations that could have developed far earlier than anything previously thought possible. Studying these older regions might reveal hints about the early conditions of the universe and shed light on how galaxies and stars formed in these early periods, potentially offering clues to life's origins on Earth and beyond. Despite the excitement surrounding these possibilities, scientists are proceeding with caution. The JWST's observations are complex, and interpreting redshift data at extreme distances is challenging. Instrumental errors, data misinterpretation, or unforeseen cosmic phenomena could all potentially explain the anomalous age without requiring a complete overhaul of cosmological theories. Ongoing studies are essential to confirm whether this massive structure truly defies our understanding of time and space or if it represents a more conventional object that simply appears unusual due to observational factors. The James Webb Space Telescope has continually pushed the boundaries of what we know about the universe, uncovering unexpected mysteries that challenge our fundamental assumptions. While this structure may ultimately have an explanation grounded in known physics, the excitement it has sparked highlights the JWST's role in expanding our view of the cosmos. Its findings prompt scientists to ask questions that were once thought impossible or irrelevant, encouraging an openness to rethinking even the most foundational aspects of physics. Regardless of the outcome, this discovery underscores the vastness of the universe and the limits of human knowledge. We have only begun to scratch the surface of understanding the cosmos, and each new discovery, especially one as potentially groundbreaking as this, reminds us of the many mysteries that lie beyond our grasp. As astronomers and physicists continue to analyze data from the JWST, we may soon find answers to these perplexing questions or, just as likely, uncover even greater mysteries awaiting explanation. The James Webb Space Telescope has not only expanded our view of the universe but also challenged us to rethink what we know about the very nature of reality. The possibility of a structure older than the universe suggests that there may be more to existence than we currently understand. Whether it leads to a reevaluation of the Big Bang Theory, supports ideas of a multiverse, or simply reveals new physical phenomena, this discovery marks a milestone in our exploration of the cosmos and sets the stage for an exciting era of scientific inquiry and discovery.